Okay, so as I said on Wednesday, so both homework 1 and homework 2 have been posted. Homework 1 is due tonight. It is a survey to check in with where you are at in your software development careers. There's a bunch of questions about Git and C++ and algorithms and computer architecture. And the idea with it is that I will use your answers to assemble final project teams. If I will be sending out information shortly on how you can also choose to create your own teams. It'll either be like an email or you'll see it. Good. So yeah, please answer the survey truthfully. Do not try to get like the best score because that may negatively influence your team in the end. It may turn out that turn out that the team that you join. Maybe no one is an expert on Git or something. So yeah, please answer as truthfully as possible. Any incorrect answers will not be accounted against your grade. It is just all for participation. Okay, cool. That's homework 1. Homework 2 has also been posted. Homework 2, we already chatted about it, but I just wanted to pull it up again. So yes, so this is homework 2. Actually, first I'll show you. So this is the tar file that I have opened. So tar file, this is a tar is similar to a zip file. So when you go on Canvas and try downloading this file, you may be confused. It's like, oh, that's just one single file. This is a zip file. You will have to extract it either with 7-zip or via the command line. And then once you extract it, then you will see the assignment PDF, which I have opened here. And the main purpose of this assignment is just to get all of the tools installed on your computers. So yeah, you will need to just install everything, and yeah, it shouldn't be too tricky overall. Section will start next week, and when you go in for your section, the goal of section next week is to exit section having 100% completed homework 2. It can be kind of challenging installing WSL and getting everything working, and it is your job, specifically in this class, to learn how to use your own computer. And I know it kind of sucks sometimes, it's like, oh man, I wish I didn't buy the MacBook because it makes it that much harder or something. But you are kind of stuck with the computer that you bought, and so you need to learn how to debug your own computer if things break. And undoubtedly, things will break in this class. And yeah, this class is kind of meant as a way to practice your debugging strategies. Anyways, okay, cool. So the main kind of coding part of this assignment, though, is very straightforward. All it is just implementing a clone of Echo. So the idea with Echo, the command line tool, if I wanted to run Echo, I can just type echo. But the idea with echo is that when you type in something, so if I say echo hello, then now it will print back whatever I type in here as an argument. And I figured it probably would just also be helpful to maybe just walk through, in my opinion, how to create a program that would do this for you. Has anyone done command line interfaces before where you have to worry about text that comes after typing in the application? Has anyone had to do this before? Okay, yeah, so not too many of you, so I figured it'd be helpful. Okay, let's say you were given this task, right, by your boss or something, or maybe in a homework assignment. What is probably the first thing that you would turn to? You're kind of incriminating yourself if you answer, but what's the first thing? Maybe Stack Overflow or something, or maybe you'd go and look up C++ documentation. For me personally, this is a perfect job for ChatGPT, right? It's just asking to be like ChatGPT. So let's pull up ChatGPT and see what it gives us. Okay, so cool. Okay, in this class, we're going to practice using ChatGPT. I see a lot of people who don't use it to its full abilities. So I want you to all turn to the person next to you, and tell them a prompt that would probably just right off the bat give a perfect implementation of Echo first try. So okay, go and tell the person next to you. And in fact, actually, maybe even better, maybe go on ChatGPT right now, pull it up, and try typing in a prompt that would finish this assignment for you. All right, go. I'll give you a couple minutes. Maybe try working around this. Oh, and if you want, you can use any other large language model or something. This is an in-class exercise practicing using large language models. You could, if you want, use documentation to go through it on the actual assignment. But for this in-class example, please use some sort of large language model. Yeah. Okay, I'll give you another 10 seconds. I'm going to ask someone to volunteer to give me a prompt to type in. Okay, any volunteers? Yes? How to echo a what? A stream into an output.txt. Okay, sure. So let's see what happens. So if I do this, is this similar to anyone else's prompt? I feel like this is not quite what we're looking for because, yeah, actually what it shows us is it shows us how to use echo. It actually shows us how to put some bit of text into an output.txt. That's not what we're looking for, though. Instead, what we're looking for is we're hoping for it to implement echo in C++, right? Okay. Yeah, another person. Okay. Yeah. So, okay, right, using C++, write a program to, do I say that one more time? Emulate the echo command. Yeah, I really like that. Okay, let's see what happens. Okay. Cool. Okay. Okay, seems overall pretty good, right? I mean, I don't know what any of this code does, but let's just see what happens. Okay. Let's say we wanted to run this code. What do we do? So probably we'll create like a main.cpp, right? Okay, and then we can probably paste this in just directly. How do we compile this code again? Close, yeah. What is it? What's the command? G++, cool. Okay, G++, and then we can put in main, all of our source files, so we'll say main.cpp, and then we want to export it. We want it to have the output, probably just be main, and then I'll do and/main to run the executable after it successfully compiles. So I'll hit enter, and okay, cool. So nothing printed out. So maybe that's correct, right? Let me try seeing what happens. So if I do /main hi, oh, there we go. Okay, hi there. Ah, very good. Cool. So it looks like it's working, right? Has anyone seen this notation before? Okay, cool, great. So a lot of people have not, but so this is a very common style of notation across languages. Maybe it'll be slightly different, but there's this these keywords usually, or these kind of common names for receiving command line arguments. It is argc and argv. And so argc is the number of arguments that we are receiving, and then argv is the list of all of the arguments. So maybe instead of this exact like code right here, maybe instead what we'll do is just try to print out each of the arguments. Maybe in each argument is on like a new line. So okay, so maybe what we'll do, is we'll say, so for int I equals 0, and then I is less than what number? Argc. Yeah, so this will now give me all of the different whatever members. Okay, and then now I can probably do std cout, and then argv, right, of what? I, cool, thank you, and then std end line. Okay, and let's try running this now, and I'll put in these two again. Okay, cool. Well, this is weird, right? So before it just printed out hi there, but now it's printing out an additional thing. What's the additional thing that it's printing out? Yeah, it's also printing out /main. Okay, so this is kind of a cool thing as well, so I'm not sure how many of you have seen this, but when you use this very common style of getting command line arguments, like across languages, you will get this list of arguments, and the first one is always the name of the program that is being run. So here we are running the program called main, so that is the first thing that we are given. So therefore, if we look at this code, maybe it'll make a little more sense now. So when we look, the first thing that is checked is we are making sure that argc is at least 1, or is greater than 1. Because if argc is equal to exactly 1, then how many command line arguments have we received? 0. Yeah, so if argc is 1, then that means that the only thing inside of our argv array is just the name of the executable. Yeah, okay, cool. So then what happens is, then we set I equal to 1, because now we want to get argv starting at index 1, and then print everything past that. And then it looks like, cool, and then it prints out spaces in between everything except for the very last one, and then, cool. Good. Can it make sense? Right? Okay. So so this is basically all the code that you need for homework 2. So hopefully you've memorized this. It seems like ChatGPT was like really helpful there. And you probably could have figured that out. You could have toiled away at some documentation and stuff. But the learning outcome of homework 2 is just getting everything installed and getting everything, like all the debugging parts for the tool installation, done. That's the most important part. The actual code itself is not the important part. And that kind of goes for most of this class, actually. I will be talking a little bit about C++ notation, but for the most part, the hardest thing in modern day software engineering is actually just the organization of files, or the debugging of large software projects, or how do you manage across an entire team. If I need to write like a Python script or some sort of algorithm that is like a kind of a small thing, maybe just a single function, I'll almost always just ask an LLM to write it for me now, because it just saves so much time. Like this is super straightforward, and I know I could do this, but it would be much faster if I asked ChatGPT to. Cool. Okay. And this all goes along with the course policy that is in the syllabus. Good. Okay. Any questions? Feeling good? Okay. Excellent. So the next thing is, we ran this command, g++ main.cpp -o, right? What do people usually run, though, in order to build projects? Like when you're at home, what do you do? Like do you write G++? Does anyone write like C++ in their free time? And they're like, I just love writing C++. And what build system do you use? Can I ask? Use a makefile. Okay. Has anyone used a makefile before? Okay, cool. Anyone written a makefile from scratch? Okay, good. we're going to write a makefile from scratch right now. You will be writing quite a few makefiles in this class, and so I want to walk through how to create makefiles. So makefile is it's a language type of file build system that was developed by the GNU team. The GNU team is a collection of engineers that all write open source software. And another type of software that is like closely affiliated with the GNU team is Linux. Linux is probably the most popular open source code base open source software that exists. Linux is run on billions of computers across servers and phones and toasters, like basically the default operating system on anything. Oh no, that's unfortunate. Well, dark-eyed Junko. Yes, okay, so let's create a makefile. Oh, good. Okay. So the way that you create a makefile is it must be called makefile with a capital M. And then inside this, then the first thing that you type is the target of whatever thing you are trying to create, like whatever file you are trying to create. So in this case, what file are we trying to create? If we were to translate like this command that we typed in into the makefile. Main, yeah, cool. So let's type in main. So main, so this is the file name that we are trying to create. Okay, cool. And then the next thing that we put after that is all of the files that are needed to create main. So what are all of the files that are needed to create main all the files that are needed to make main? You can just shout it out. Yeah, so in this case, it's just main.cpp, right? .cpp. So what we are saying here is we want to create the file main, and we are going to use the file main.cpp. And then inside that, after this, we will include all of the different commands that are needed in order to generate main. So if we wanted, we could say something like touch main. So this command, touch right here, touch will create a file with this file name. And if the file already exists, then it will just update the date of when the file was created. Like it'll just change the date, but it won't actually change the contents. So let's go and test this out. So if I now run make main, actually first let me delete this main file. Okay, so I've deleted this. Currently main does not exist. Okay, I'm also going to clear this. Okay, clear. Sorry, trying to make this pretty looking. Give me just a second. I think that'll do. Okay, cool. So now I'm going to type in make main. And whenever you type the word make, that means that in the current directory, it will now look for a file called makefile. So I will run this, and there we go. So now we can see what commands were run, and we can see that touch main was run, and if we hit refresh, then now we have main. Of course, this main file is not actually our compiled binary, because all we did is we just created a blank file. So now inside of here, what should we type instead that will generate our executable? Yeah, g++ main.cpp -o main. Cool. So now when we type in make main, ignore that for a second. Okay. Then there we go. So now we have created this main, and and this is all now correct. Cool. But now watch what happens. So if I run make main again, now it says make main is up to date. Okay, so, and this is because main already exists here, right? But what if now we wanted to change this file? Like maybe I want to get rid of this code up here that I added, so I comment out this file. Okay, what will now happen when I run make main? Okay, turn to the person next to you. So I just edited this main.cpp file, right? That is required to generate this main executable. So what will now happen when I run make main? So I just edited this file just a second ago. So okay, turn to the person next to you. What's going to happen when I run make main? Okay, so we already have this main executable, right? Like this file already exists. So if I run make main, is this file going to be like overwritten, or is it going to also say like, oh, main is already up to date because it already exists? So raise your hand if you think main is going to get overwritten. Okay, raise your hand if you think it's going to say main is up to date. Okay, cool. So let's try it. Okay. Oh, look at this. So was main updated? It was, yes. We can see G++ was run one more time, and now it overwrote this main file. Yeah. And this is the whole kind of great thing about makefiles, is what a makefile will do is when you try running a target, so when I say make main, the first thing it will do is it will check, okay, does this main file, or sorry, actually, so the first thing that it does is it looks at all of the dependencies, and then it tries to make all of the dependencies. And in this case, main.cpp already exists, so it doesn't need to make anything. But then what it does is it checks the time at which this was most recently updated. And so we can see that if main.cpp was updated more recently than main was updated, then that means that now main will need to be regenerated because main.cpp is now like more up to date than main, so therefore main will need to get overwritten. So if we created like another file now, so if we created like b.txt or something, right? And I don't know, let's create b.txt, sure. And now, if we run make main again, then now what do we think will happen? Will it say up to date, or will it say like G++ is run again? Okay, raise your hand if you think G++ will be run again. Okay, so let's test it. So okay, it looks like it was run again. And that's because now we are expecting b.txt to be a part of the dependencies list. And if I now say make main again, main is up to date. If I now go and change b.txt, and I say hi, then now it will be regenerated, G++. Let's run again. So that is the idea with makefiles, is you have your target and you have your dependency. Okay, so now really quick. So let's say maybe we wanted to create b.txt. And maybe b.txt now relies on a.txt. And maybe what we say to create b.txt is maybe we will copy over a.txt into b.txt. Okay. And then maybe we also have a way of generating a.txt, and we can just say touch a.txt. Okay, you ready for this? So now if I go and delete b.txt and main, okay. Now, what will happen if I type in make main? What are all of the different commands that are going to be run? Tell the person next to you, what will be run in the terminal when I type in make main? Is that lighting any better? Or is it, okay, cool. Okay, I'm now going to run it. I want you to turn to the person next to you after I've run it and be like, haha, I was right. Or say, ah, dang, like, I don't know why that happened. Okay, you ready for this? I'm going to hit run. Okay. Oh, okay. Is that what we were expecting? Okay. Can someone walk me through why each of these commands were run? So the first command that was run, what was the first command that was run? Go and just say it, shout it out. Touch, yep. After that, then we copied the file. Then after that, we ran G++. So what happens is first, so we say make main. So we look at main, and we see, okay, like does main.cpp exist, and is it like newer than main? Okay, so it checks that. Probably it will see that, that I guess main didn't exist. So, so therefore it knows that it needs to build something. But then it'll also try looking at b.txt. And it'll realize that b.txt does not exist. So now it will try making b.txt. So then it'll start running this target. And when it tries running b.txt, now it'll look at the dependencies, and it'll see, oh, I need a.txt. And so then it will look at the a.txt target, and then now it will create this file. And watch what happens. So if I do like make a.txt, okay, so this has no dependencies. So what do you think will happen if we run make a.txt? What do you think will happen? Will it say up to date, or do you think will it say touch? Okay, tell the person next to you. You can put money on it. Okay. All right. Okay, I will run it. It says it is up to date. And that is because there are no dependencies. So as soon as it's created, it knows like, okay, like there's no additional like things that I need to check. Like there's nothing that's going to tell me that this file will become out of date. Versus if like a.txt relied on another file, maybe I had another source file that a.txt relied on, then yeah, it would need to check if that file was newer than a.txt. Cool, so therefore, yeah, if I say make main, there we go, it says main is up to date. Okay, now what would happen if I tried deleting a.txt? So I'll try deleting this. Okay, you ready for this? Okay, now what do you think will happen if I do make main? Okay, I'll try it. Oh. Is that what we were expecting? So if you remember, so what I did is all of the files existed, except I deleted a.txt. So now what's going to happen is we look at main, and we run make on each of these. Main.cpp, like anytime you have a file that like already exists, then it does not, and also does not have like a target, I guess. Like I guess we could imagine that there's like an implicit like main.cpp target here, I guess, that just has no commands and no dependencies. Right, so that's what this like dependency is notating, is like a kind of like an empty dependency that we're just reading the time from it. We're not trying to build it. But then b.txt, we can see like, okay, this does have a target. And since this has a target down here, we also now need to check that all of these dependencies are up to date. And I guess the purpose of that is like if I now said, yeah, so okay, let's run this again. Well, we can see that main, like in a way, actually relies on a.txt. Because first it relies on b.txt, but b.txt actually relies on a.txt. So we could also come in here and we could change a.txt. And we could say, like, changing this for b.txt. Okay? And now if I do make main again, then yeah, then it's once again rerun, because now we needed to update b.txt, because now here's b.txt. Okay. So this is great. So make files, overall, very kind of straightforward. You basically just say like what file you want to create, and you say all of the files that are needed to create that file. And you just do that for all of the different files that you need, and it will automatically generate a dependency tree for you. And so you don't really need to worry about like every single, you don't need to worry about the order of like when things are compiled. All you just say are like what each target relies on, and then it'll figure out the rest for you. And in fact, like if like I'll write massive makefiles. I'll write makefiles that are like 200 lines long. Like you see the makefile that I've written for this class like final project. Like it's real intense. And for large makefiles, this is not really all that applicable right now. But you can also just super easily enable multi-threading. You can just type in make main. You can do -j. J means jobs. So I don't know if any of you have like tried compiling like large open source C++ projects before, or just open source projects using makefiles. Oftentimes you will see in the documentation, it's like, hey, like please compile our project using -j, because now it will enable like all of the cores in your PC. In my case, I think I have 22 cores or 22 threads at least. So yeah, I can run this. And unfortunately, it's not going to do very much because there's not even close to like 24 jobs to be done here, so it's done like immediately. But anyways, makefiles, really great. The more you use them, the more you love them. I really like makefiles. Okay, cool. I'm going to show you another thing though. So you can actually make makefiles a little bit more clean, I would say, with a couple features. The first one is when you have a target here, you can actually replace the target name with this variable, which is $at. $at in like a specific, like in all of the commands that come after the target name, $at, this will elaborate out to the target name. So I can come in here. So which one of, like what here can I replace with $at? Yeah, it'll be b.txt because that's the file we are creating. So I can say $at. And then similarly here, what would I want to change? a.txt. Yeah, right. There we go. Cool. So let's try running this. Oh, you know, I'm also going to create another target. And this is going to be called a phony target. Phony target means it doesn't actually create a file. Instead, all it does is it just runs a command. So I'm going to run the command rm, and we'll do -f to delete file, or to not error out if the file has already been deleted. And we will just delete all of the intermediate files. So we'll delete main, we'll delete a.txt, and we'll delete b.txt. Okay, anyone seen make clean before? Make clean. This is very popular. Yeah, so I'll type in make clean. So now this will delete all the files. Another cool thing that you can do, I don't know if anyone has seen this. So notice how I say make cle. Well, if I hit tab, then make files are really great and will actually autocomplete targets for you. So if I hit tab, then there we go. Auto-completes the target. And here it's not as useful, but you can imagine that if you have like a huge make file, as I often do, with 100 different targets in it, it's really nice to have that target like autocomplete feature. Okay, kind of cool. Yeah, question? You absolutely can. Yeah. So good point. So you can autocomplete for other commands. If you are writing your own command line interface, though, you will need to implement that feature. Yeah. But yeah. So for other commands, you are able to do tab to autocomplete. And if you're ever like going through a directory structure as well, then you can also tab to autocomplete. Like if I whatever, cd, whatever, I can come back to this directory if I do whatever, CSE1, and then I can hit tab to autocomplete this out, boom, and then I can autocomplete the next part if I say 1.1 and then tab, boom, there we go. So I'm now back in my directory. So tab, really, really helpful. Good, hopefully. Yeah, I'll probably just throw in a bunch of other random like Unix shortcuts as the quarter goes on. Okay. Good. Cool. Make clean. What was I going to do? Oh, yeah, right. So, yeah, we can see. So if I do make main, then it's still, make main. You can see that it still works, and it still runs each of these commands, even though I've now replaced it with $at. Another very useful thing that you can do is you can replace the dependencies list as well with a variable. And in this case, does anyone know what variable we can replace this main.cpp with to grab the very first dependency? Does anyone know? It'll start with $, and what's the next symbol? So it will be $, and then less than. $, less than. So $, less than will grab the very first dependency. Okay, and then there's another useful macro, $caret, and that grabs all dependencies. Okay, there is, $at, grabs the target. Okay, good. So here we can say that. Cool, good. There is another useful thing that I want to show you. So, as a couple of you have thrown out, oftentimes when you compile C++ code, it actually isn't the best idea to use this -o. The reason for that is because, like in this case, it's totally fine. But if you maybe had like 100 C++ files that you were all compiling at once, it's really nice to compile each of your files in like a different stage, and not to just compile everything at once and then create a single executable, because that could take like 20 minutes, right? But it'd be nice if you only change like one single file, that only like one part of your program needs to be recompiled, and then I take it back. I think I'm going to prepare a better example. I had an example planned in my head, but I don't think it will be as strong as the one as what I could do instead. So I can take back. Okay. I think today was. I think this is a good kind of stopping place for today. So today, so we talked about makefiles. Makefiles are kind of the most important kind of thing that I really want you to get out of this class, today's lecture, because makefiles kind of are, in my opinion, the most accessible way of creating build scripts for all sorts of like software projects across C++ projects, all the way through really any time that you have to deal with multiple files and creating multiple files. And then I'll create a better kind of header file example. So that for homework 3 you will be better prepared for that. So question. Let's keep it down. If you need to head out, that's totally fine. But class is still in session while a couple of questions are being answered. Please continue. Oh, good point. So the question was, how do you get this? So if you download this homework 2 file, the question now is, how do you get this into WSL2? All right. So there's a couple ways to do that. In my opinion, I think the best way. So I guess for those who are using WSL2, so what I would do is so I would download this file, and then maybe I would drag it into whatever working directory I want. So for me, I'll just I guess this is the homework 2 file, but so I'll drag this in here, and so boom, now I have this file, and now I can extract this file. And does anyone know how to extract a tar file from the command line? Anyone? Okay, I'll tell you the command right now. So the command is tar-x to extract, and then Z to unencrypt, and then F to give the file name, and then we will type in homework 2, whatever, hit tab to autocomplete, and then hit enter. And now this will extract out all of the contents. And so now we can see this assignment, and we can see the starter files. And then you can get started from there, Right. Cool. Any other questions on homework 2 or anything? Question. Yes, good. So I will create a submission box for homework 2 this weekend. Cool. Okay, thank you, everyone. I will see you on Monday.